Hello friends, today we'll be doing a question related to Z transform and the question is as follows. Okay, he is saying that the inverse Z transform of this is x of n, then what is the value of x of 0? Okay, so already he has given the Z transform and he's saying that inverse is x of n. ROC is also given to us, which is mod of Z more than a. Is asking us to find the value at x equal to 0. So let us proceed. So here what we can do is first we can take the differentiation of this x of z expression. Okay, why we are taking differentiation is because there is a log term, so we may be able to use some property here of differentiate of z transform, so we are differentiating it once. So what we do is we differentiate it as d with respect to z, and this is with respect to z. Okay, it is differentiation. So dxz over dz is d by dz of log of v 1 plus a z inverse. Okay, so this is the expression for the differentiation, and what we get is log of differentiation of log of x, say is with respect to x, or is 1 over x, so with respect to z is 1 over the expression. Okay, plus into the expression which is inside, and this expression is 1 plus az inverse. Okay, so after that what we do is we have to differentiate this part as well, and this 1 is going to give me 0, and this a z power minus 1 is giving me the differentiation as minus a z power minus 2. Okay, so what I get is minus a z power minus 2 over 1 plus a z inverse. So now what we are getting, dxz over dz is equal to minus a z power minus 2 over 1 plus a z inverse. So now what we think is we try to use some property of differentiation, property of z transform, which may hold here. Okay, so let us see what we can do. So I'll again be writing this expression in the next page, and I'll be explaining. So again, see d by d dx over dz is minus a z power minus 2 over 1 plus a z inverse. This is what we got by differentiation. But we know that one property of z transform says nx of n is having a z transform of minus z dxz over dz. So he's saying that this will have a, what we can say, this has an inverse z transform of this. Okay, because these two are z transform pairs now, so it is having an inverse z transform of nx of n. Now to do that, what we need to do is we need to multiply the expression 1, okay, with respect to minus z. Okay, that's what we have done here. We have multiplied it with respect to minus z, so we get minus z dxz over dz equals to a, it is a z power minus 1. Why? Because minus z is there, so minus z will make this minus plus. Okay, and again because of 1 z we have to reduce the power by 1. Okay, so now our expression boils down to this. Okay, now for this expression on the left hand side, minus z dxz over dz, we know the inverse z transform, which is x of n into n. Okay, or nx of n, like this is the property of z transform. So now what we need to see is what is the z transform of this. Okay, to know the inverse z transform, the inverse z transform of this, to know the inverse z transform, let's look at this place. Here we know that the inverse z transform of 1 over 1 plus a z inverse is minus a power n u of n. Okay, and this is the z inverse z transform only when mod of z is more than a. Okay, we should always remember this. Why this is important, this ROC is important, because mod of z more than a, then only this will hold. Okay, so minus a power n u of n is the z transform of this. Now when we multiply it with z inverse, the z transform inverse, okay, the inverse z transform is going to be minus a n minus 1 u of n minus 1, because of the delay property. Okay, because of the delay property there is a z inverse which comes into the expression. So now we have z inverse over 1 plus a z inverse, its inverse z transform as minus a power minus a power n minus 1 over u into u n minus 1. Okay, now the same thing we can write here. Okay, so what we have written here is, see, thus that transform we have now done the inverse that transform both the sides. Here it is n of xn, and here it is this part z inverse over 1 plus a z inverse is minus a n power minus a power n minus 1 into u of n minus 1, and an a is already present there, so we write it as it is. So now x of n is, we take that n down here, okay, by cross multiplying, and we get x of n is equal to a into minus a power n minus 1 u of n minus 1 by n. Okay, so this is what we are getting now. So now we have this expression of x of n. Now what we can do is we can calculate x for any value of n now. So let us see what x of n actually is. Okay, so x of n is given by this expression, and this expression is 0 for n less than 1, and it is a minus a power n minus 1 over n for n more than equal to 1. So in our case he's asking us what is the value at x equals to 0, so which is less than n minus 1, which is less than 1, so it is equal to 0. So the answer for this question is D. Okay, so this is how you need to proceed for a problem involving log. Okay, so thanks for watching.